This is the midterm level question that you're supposed to solve for scheme. And so in this question, you're supposed to implement a function called corrupt check. And corrupt check should basically check whether the inputted list has a value equal to any of the digits of n. So the first step would be to look through the doc tests, and after you understand the question, you should try filling out this skeleton code. So I recommend you pause the video and try this out yourself first before going through the solution. Assuming you've paused the video, I'm now going to walk through how I would approach it. Alright, so I would start off by trying to understand the doc tests. So for corrupt check, it's going to take in a list as the first parameter, right? And n is going to be an integer. So for the first doc test, it's an empty list, and of course n is not going to be, so any of the digits of n are not going to be in this empty list because it's an empty list, right? So we'll be returning false. Okay, and in our second doc test, we have this list, and n is 23. So we're going to be checking if each of the digits of n, or either of the digits of n, belong in corrupt check. So I would check if 3 is in this list, it's not there. And is 2 in this list? No, it's not there. So we return false. Okay, makes sense. And this last case, so I have the number 6832. So I'll check, is 2 in this corrupt check? It's not there. Is 3 here? It's here. So we return true because 3 is in corrupt check. Okay, I think I understand the question. And this is my skeleton code. So notice, like, unlike Python, Scheme lets you use several parentheses on the same line. There's no restriction in terms of indentation, but it is a good idea to indent your code just so that it's easier for you as well as other people to understand and debug. Okay, so we're given this blank space over here in the helper function, which means we probably need to write something here, and then we have a call to this helper function with 2 parameters. Okay, 2 inputs. Neat. Okay. So I would first approach this by just thinking about how I would solve this problem, right? So for corrupt check, I'm gonna have a list, right? And I'm gonna have n. And let's say n was the number 89, and let's say my list was just 3, 2, and 1. Okay, so of course none of the digits of n are in my list. So in that case, I would return false. Alright, okay, I'm gonna start off with the simplest case. The simplest case would be like if n is 0, right? And if my list is just nil, I know that it's going to be false because n is not going to be in nil, of course. And in fact, if n is anything other than 0, it could be 89. If n is 89 and list is nil, since list is nil, I know for sure that n is not in my list, so I would return false. So I guess that could straight away be one of my conditions. So I could have written out, so I could write out cond, right? The first condition is going to check whether my list is nil, right? Okay, so I'm going to check if list is nil, right? So this null is going to check if my list is nil. And I need to check if my list is nil, and if n is 0, I need to like stop, essentially. Or if n is anything, essentially, I can stop here, right? So I could just possibly return false here. Okay. This is the base case, I guess. But if I were to have something like this given to me, so with list as 3 to 1 and n is 89, the way I would actually check if any of the numbers of n were in list is that I would first look at the last digit of n, because that's like the easiest to access. I know I can access the last digit of n just by doing modulo n10, so it's n mod 10, right? It would give me the last digit. Okay, and I would compare it to like this position in the list, so this element, so car of list, and that's 3. 3 is not equal to 9, so I would move on to the next element in my list. So I move my pointer to this, and I'll compare this element to 9. They're not the same, so I'll move to the next element in my list and compare values. They're not the same, so what I would do is now I would change my n. I've been comparing n, 9, right, this whole time. So I'm checking if 9 is equal to this first digit, the second or third in the list, right? So now I want to compare another digit, like 8, which means I need to change my pointer, which was initially here, right? So right now my pointer is here, because I was comparing each of these values to n, and I've reached here. But now I need to restart this pointer and make sure it goes back to the beginning in order for me to compare this list with this new value for n mod 10, because now n mod 10 will be 8, because I'm going to basically pass in a different n and then compare this value, so this 8 with all these values. Okay, because of that, I guess I would always need a pointer to point to the head of the linked list, because at each iteration, once I finish going through this whole list, I need to come back to the first element in order for me to change the digit in n, which I'm comparing to. Okay? So in our code, it looks like we have car, the variable car, and the variable list. And list is going to point to the inputted list. And I guess car might be these pointers, which I keep changing, because car indicates that it's the current element, right? And all of these things seem like they could be the current element, because we're going to be currently comparing this digit to n, or 9, and this digit to 9, and this digit to 9, right? The current is going to be changing each time. Okay, so based off of that, I know that I would essentially stop my code not when list is nil, because list is never going to change in this version of my algorithm, right? List is not going to change. So instead of checking if list is null, I'm going to check two things. So I'm going to check that current is null, right? And that n is 0, right? So I'm going to check the two things, and it's an AND condition. So, okay, I'll have an AND over here. So I'm going to check if current is null and if n is equal to 0. Because if this condition is true, right, so I have my AND, closing parentheses, yeah. So if this condition is true, I know that I'm basically done. If n is 0 and my current is null, it will be something like this. So it'll be, I basically finished reversing the whole list, and I know I've not found a digit of n yet, so I return false. The reason I'm checking if n is equal to 0 is because I might have something like this, right? I might have current over here, and let's say current has reached the end, so the last node. And let's say n is 89, and 9 is not equal to 1, right? So at this point, current will change to nil, right? So I'll change my pointer to nil, like the end of the list, basically, the rest. So current will change to nil, and n will still be 89, but I shouldn't terminate my code here, because at this iteration, I've been only checking if 9 is in this list. I haven't checked if 8 is in this list yet, which means this is a different case. It's not this case. It means I still need to continue checking. I can't return false just because 9 is not in this list, because one of these elements might have been 8. And at this point, if I was checking for this n, I would now need to reset the pointer for current to the beginning of list and now check if 8 is in the list. Okay, so this is one condition. I guess the other condition is, yeah, what happens when current is nil, right? So if current is nil but n is not equal to 0, I know I need to reset the pointer for current to point to the beginning of list and change n, right? So that's the case when current is nil. So if current is nil and if n is not equal to 0. So I know in this case, n is definitely going to be equal to 0, because in the previous part, I checked if n is equal to 0, and if current is null, it'll go to false. It'll only come to this line over here if it hasn't gone to the previous one, right? And if it hasn't gone to the previous one, it means that either current was not null or n was not equal to 0. If it were to go into this condition, it's going to be checking if current is null. And I can definitely assume on this line that n is not equal to 0, because if n was equal to 0, it would have gone into this piece of code right here and returned false. Okay, so I'm checking if current is not equal to null, and if n is not equal to 0, what's going to happen is I'm just going to change the pointer of current and call my helper again. So I'll be calling helper, right, with a different value for current. So current is just going to be the head of the list. It'll just point to this, right, the head of the list. And n is going to be a different n, right? So if we are comparing the last digit, now we're going to just change n to remove the last digit. So I would use quotient. So quotient is the same thing as floative, right? So quotient of quotient n10, this will just give me this part. So if n was 189, it'll give me 18. Okay, so I'm changing n and basically going through the list again, right? It's my call to helper. So that's one more condition. What else? What if I find my value in this list? If I find, so let's say n was 1893. 3 is going to be an element in this list, right? So that condition is just if the car of my list is equal, so car of not list, car of car. If car of car is equal to the last digit of n, right? So if n is 1893, I know if I do modulo n10, that'll give me the last digit. So if the last digit, so if modulo n10 is equal to car of car, I know I found a digit of n in my list, which means I'm going to be returning true. Note that it's important that this line comes after this line, because we need to make sure that car is not null. If car is null, we can't call car on it. That's why we have this checking for this condition which checks if car is null over here and here, which means on this line, we know for sure that car is not null, which means we can call car on car. Okay, cool. So this is fine. What's the other case? Is there any other case? Yeah, the other case is, I guess, if car is pointing to this node and n is non-zero, I need to just change the pointer of car to point to the next node, but not change n, right? Because we're still comparing the same digit. And that, I guess, would be our last case. So I'm just going to write else. So else, I'm just going to call helper again, and I'm going to change my pointer. So if it was pointing to car, Okay, car will just change to the cutter of car. So cutter of car, right, will give me the rest of my list. And I'll keep n the same because I need to still check for the same digit, right? So I'm going to call this helper function in this else clause. And I'm just going to make sure that I've closed all my parentheses. Okay, I need to close my parentheses for cond. So I'm just going to do that. Ideally, it should have come like here, just the way I indent things, yeah? So I'll just draw it out over here. So I've closed all my parentheses. Okay. Oh, and I've not filled in this helper call, like this function, the call to helper. I need to fill that in. So what will that be? The initial head that I'm going to be passing in for car. So car is initially going to just point to the beginning of list, right? And n is just going to be this whole n initially. I'm going to just pass in list over here and n over here. So car will now be list and n will be n, yeah? And okay, I'm now going to test my code because I'm not sure if I messed up or not. So the way I test code is just take a dummy test case and run it through your code. So in my test case, I'm just going to use, let's say, list is going to be the list 1, 3, 2. Oops. Okay. 1, 3, 2. And car is going to be a variable which will initialize inside the function. And we're going to have n, which is going to be, let's say, 5. Okay. Or 15. Okay, even 15. The way I would test this is, okay, I'm going to assume I've passed in these inputs here, which is corrupt check. It'll then go to my my helper function. So it would go to my helper, right there. And it will go to my helper, and after it's gone to my helper, it will call the helper function. So it will call this thing over here. It will go inside this. At this point, car is not null, so I will not go through that. I'll not go through this. I'll not return false, basically. I'll come to the next condition. So car is not null. I'll not go through that either. Is car of car equal to mod 10, n mod 10. So n mod 10 at this point is 5. 5 is not equal to 1, so I won't go in there. Now I come to the else, so I will call my helper on the cutter of car and n. Okay, I'm going to use the leap of faith here and assume that helper works. And that's just to save time whilst testing my code. I'm going to assume that helper works, which means I'm going to assume that helper does, in fact, check if the list has n. So it'll check in this case if the cutter of car has n. So if car was this now, it'll check if the cutter of car, which is this, has n. I'm going to assume that works. And assuming that works, it'll return whether this list has n, right? Because I know for sure that this element doesn't have n or digit of n when I'm here, right? So yeah, based off of that, I know that when I reach this line, and if helper works, then my corrupt check will work. Okay, that's just using the leap of faith. I do, however, need to check my base cases to be 100% sure that this works. Okay, so I would check my base cases. I have, so one of my base cases is when list is nil. Sorry. So if list is nil, and sorry, if list is nil, right, and n is a non-zero number like 15, will this work? So in that case, let's see, car would be null and n is not equal to 0, so it will not come into this part. Car is null. Yeah, car is null, so it'll come into this line. So it'll evaluate this function call. It'll call helper on list, all right, and we're basically reducing n to be 1 instead of 15 now because we're using quotient n10, right? So now the new n passed in is 1, and again I'm going to use the leap of faith and assume that helper works. If helper works, this call will indeed return the it'll return whether corrupt check has a digit of n in any of the elements in car or list. Yeah. Okay. Cool. So this condition works. If n is 0 and car is null, for sure this thing will return false, right? That works too. Okay, what about the case when there is actually a digit of n in my list? That's the last case that you have to check for. So let's say I have 3, and then I have 2 and 1. So in this case, 1, which is a digit of n, is in my list. So on my first run through this algorithm, so car will point to this part. So 5 is not equal, so we will not go into this, right, because this condition is not satisfied. Car is not equal to null, so we won't go into that. Car is not equal to car, so we won't go into this, so we'll run else. And eventually we will get to a stage where car will point to this element, and n will be 1, right? And that will basically come into this condition, because this condition will be true, right? N mod 10 will be 1, and car will be 1, and that will return true, which is exactly what I want my helper to do. So now I've basically checked all my cases, and I think my code is correct. Yeah, so this is the solution, and I think it matches the solution given. Yes, it does match the solution given. Yeah, so it matches the solution given exactly, and I will receive full credit, of course, for this. Cool. So that's the midterm level question that I've written out for you guys. Do try it out. It's very good practice. And let me know if you have any questions. Thanks for watching.